This module covers Windows Search and some special artifacts coming from databases being kept by the Windows operating system. When it comes to Windows Search or Windows Indexing service, we have an index of everything that moves within the operating system. Especially we have some special so-called ifilters, which are indexing files according to their extensions, and everything here is stored within this under this location within a database. We cannot use this database. Oh, thanks. We cannot use this database file right now as it is in use. However, I can create a snapshot, and it should be relatively easy to read the data from it. I'm reading for my own purposes data from those databases using some PowerShell scripts. However, SADB viewer from Nearsoft may be good enough. I'm explaining in a bit in details in the module related to Active Directory database. Anyway, I will launch PowerShell ISE as an admin to create a snapshot. Is the simplest way, and copy paste will do the job for me. This is the same way of doing the snapshot I explained when Amcache was analyzed, F5, and I have this location for a snapshot, and within a snapshot I can easily use a file which is in use. So if I go here, program data Microsoft, I can launch CMD. I can create a copy as an admin. Dir C and my location, and then shadow copy, and then program data. As you can see, the location is Microsoft. There is a lot of files over here, but Windows EDB is the name of the database. I need to find it, and I need to copy it to make it analyzed with my script in a moment. Windows EDB, and I will use /A for looking for hidden files, /S to go to subdirectories, and /B to display a full path. So you can find it in a moment. I will copy it to the root of my C drive. Copy Ctrl V to the root of my C drive, because it will be handy this way, and I will copy the script and I will paste it into my PowerShell, Ctrl V, and I will go to the root. Because the script takes the Windows EDB from the current directory. As you can see here, if I start it, F5, it will analyze, it should analyze my EDB file. If I fail again with another script, it was not shut down properly. If this happens, the snutil utility snutil may help me, especially with P or R commands. I'm not sure if this one is working from the PowerShell. Let's go for my admin command line cd here, tutul, and I can repair the file. So repair is letter P. Okay, snutil /P, and then Windows EDB. Okay, let's see if the script works right now. Okay, it's in use, so Ctrl A, Ctrl C. I will close it. I can close it from the PowerShell as well. PowerShell ISE. Actually, the script should close it at the very end. But anyway, creating a new instance of the PowerShell is simply easier, and now it works. So we had a chance to fix the database as well. And here you can see what we have within the database, including what my user GT have and where it has. So this is the structure of files and folders. I can have on my drive, there were indexed, they went into the database, so I can recover the structures just digging through it. Under some conditions it may be helpful. I will close it and I will launch PowerShell ISA again with slightly different scripts I have, focusing on the file names, Control C, Control V, and I will launch this one. Hopefully the file will be okay right now as it was fixed. Let's see if I have file names, and here under my C, let's see if I have it on the desktop. I have created test1 on the desktop just to observe if it works. No, I have desktop ini, which exists on the desktop, which is text file. This one was most likely not yet indexed. In a moment it should appear here, but you can clearly see I have a file which is hidden normally. If I display hidden files, cd desktop /a to display hidden files, you clearly see desktop ini exists here. So it is in the database as it was indexed. So I have such trace only by analyzing the database, actually the recovered copy of the database I had here. So using such database, Windows is using for searching stuff, for finding things quickly when you type something here, for example. Here, for this purpose, Windows is using different types of the information, so it doesn't have to be consistent, but anyway, such database exists, and it is somehow useful in practice, also for some forensic purposes, to dig through it, to figure out what went to the database. Even if the file can be deleted, it will still remain within the database, giving sometimes quite valuable forensic findings. Another thing I would like to mention is related to the file history. We have a feature called file history in Windows 10, Windows 11, providing us a copy of everything that moves on our drive. If we specify a folder, the history of this folder is periodically stored on another drive, and we can have quite long trail of the data being changed just for a backup, for restoring stuff, etc. And as well, this information is being kept in a database using the same as a database type as we have for search. When you take a look for the history, it is from my host. I can go for videos, for example, and you can see a history of my videos. If I remove one of those from my drive, from my C drive, it will remain in the history and I can recover it. I can also move back in the history, trying to recover a version of the video that was on my drive a couple of months, weeks ago. Analyzing this data is also possible. I'm providing a write-up about this, how this database is arranged. This is the official documentation. This is my research on this, a bit different, and we can try to analyze it with PowerShell and export to CSV. Entire content of every single table we have here can be exported to CSV to allow you to merge it on your own, to dig through this information, to import it to Excel, whatever. So the script analyzes it. I will not run the script right now, as I have run it a moment ago. You can see number of entries within those tables are relatively high. We have tables with more than 1 million entries. So analyzing it takes, well, sometimes hours, but we have nicely formatted, give me a second to find it, CSV files containing all the stuff which can be used for analysis using this database graph. For example, I open strings CSV. Give me a second to bring it back on the screen, and here you can see the very end of my history of my file history. Actually, literally yesterday I have played with run throttled not yesterday, 2 days ago, a run throttled executable file. I have published it on my GitHub, by the way. Then I started to work with videos for you, and you can see the history here, but I have this data. This is important here. It is not about the video itself, it is about the data I have here. Here within the string CSV I have only names, but I have other CSV exported as well, and you can easily find this information, how it is all arranged, where is the folder or not the file name, what is the full path, when the file was changed, etc., is here in the database, allowing us to dig through this information. So even if user removes something, we can verify when it was removed according to the database content and so on. The only bad news for you when it comes to the file history, this one is not turned on by default. Index is turned on by default, file history is not. The third artifact I will show you is turned on by default, but I will leave it as a kind of a homework for you, because this one is related to the indexing things related to some other documents. So yet another database being kept by the Windows file. You have to approach it exactly the same way as you have approached Windows Search database. So create your own copy within the current folder, and then you can run it, run the script trying to draw a tree of the data being taken out of this database, providing you yet another piece of the information, allowing you to dig deeper, allowing you to discover more evidences within your investigation.